Welcome to God Academy. This is Kumar, physics professor. So now we are going to study about the new chapter, that is motion in a plane, which comes under kinematics 2-dimensional. Okay. So in this motion in a plane, the first topic is about projectile motion. So let us discuss in detail regarding this projectile motion. Kinematics 2-dimensional. In this, nothing but motion in a plane. Okay, so considering x and y plane. In that, the first topic is projectile motion. Projectile motion. What do you mean by projectile motion? Whenever a body is thrown with a velocity u, making an angle theta with the x-axis, we observe that it is following a parabolic path. So that motion itself is called as projectile motion. Clear? So initially we have studied about only one dimension. We are considering a body projected upwards along y-axis. There is no x-axis. As well as a body projected downwards. There is also y-axis. Again, no x-axis. But here, we are considering both x and y. That is two-dimensional plane, x and y plane. Understood? So, that is one difference between kinematic one-dimensional and two-dimensional. Here, if you throw a body with some velocity, what happens is that it will follow a parabolic path. The path followed by that body itself is called as projectile motion. Projectile motion. When a body thrown upwards with a velocity u, making an angle theta with the horizontal. When a body is thrown upwards with the velocity u, making an angle theta with the horizontal. Okay. Then it follows a parabolic path. This path followed is known as projectile motion. This is what is the definition. So that I will show you in diagram. Here we are going to study about, position and velocities of a body by using mathematical equations. We are studying about position and velocity of a body by using mathematical equations. Clear? So, what I am describing you here is that whenever a body is thrown upwards with a velocity u, so the initial velocity of the body is u, okay, which is making an angle theta with the horizontal. So here itself I am telling you, with respect to horizontal, the angle has been made. It means you have to think there is something else more. So horizontal I am telling, it means something else is nothing but vertical. So vertical and horizontal you are having in this particular chapter. If I draw like this is known as horizontal, nothing but x-axis. If I draw like this, vertical, nothing but y-axis. So, you have to say this one as horizontal, okay, nothing but x-axis, whereas this is vertical, nothing but y axis. Okay? Like this it is there. So, a body is thrown with a velocity u which is making an angle theta with respect to horizontal. So, with respect to horizontal, it means you are throwing a body like this. Okay? With respect to horizontal, the angle made here is theta. So, that is what the meaning of this particular definition. Is it clear? So, once it has been thrown, what is saying is that it follows a parabolic path. What do you mean by parabolic path? So, instead of going in a straight line, it has to take this path like this. So, this path itself is called as parabolic path. It has to take a path like this. Understand? So, this is called as parabolic path. The motion of the body is called as projectile motion. The motion of the body is called as projectile motion. Now we have to study its velocity at different points and its distance or position at different points. So these things can be done only by using mathematical equations. Now let us go in detail with all these factors. So now you better take a screenshot of this. I'll wait for 2 minutes. Later on I'll continue. Now let us study this carefully. Okay. So let me draw the diagram once again. A body has been thrown with a velocity u so that it makes an angle theta with respect to horizontal. Now this body is going like this and then coming like this. Observe. Is it a parabolic path? Yes or no? So this is nothing but x-axis, whereas this is nothing but y-axis. Okay. If you observe that this is not maximum, so this point is called as maximum height. We are throwing a body with the initial velocity u. Clear? So if this is initial velocity u, as we have studied in vectors, okay, if a vector is going in upward direction, so one component is along upwards and other if it is moving towards right side, it means other component is towards the right side like this. This we have studied in vectors. Suppose if this vector is A, this is called as x component of A and this is called as y component of A. Similarly, if a vector is moving like this, let it be B. So again it is upward. So one component is upward since it is moving towards left side. Another component is taken along left side. Okay. So here what is happening? This is along positive x-axis. Whereas this is also x component but coming in opposite direction. So this is negative x-axis. Whereas this is y component of A and this part is y component of B. Since it is in upwards, this is along plus j. Like this we say. Isn't it? Because in the graph, this x-axis is called as positive x and this is called as negative x. Whereas here it is positive y and here it is negative y. Like this. Okay. Now suppose let me take another vector. Let it be force, just coming in downward direction, force. Since it is downwards, one component is downwards. Since this force is moving towards right side and its component must be along right side. These things you have to understand. So if you observe here, this is along x-axis, so it is x component of force, whereas this is y component of force. Clear? Now, it is moving towards right side. Towards right side means positive x-axis. Okay. Downwards means negative y-axis. Like this, we have to consider the direction. I'll draw one more thing for you. Suppose if force or momentum or something else, you take something as you wish, P, in downward direction. Downward, so this is in downwards, in left side, you have to take its component along left side. Understand? So, since this is along x-axis, you have to take x component of P and this is y component of P. Observe carefully, my dear children. Here, this one is coming towards left side. Left side means you have to take it as minus I. So, minus along x-axis. Downwards. Downwards, as I told you earlier, it is minus j. So, minus j. So, this is the way we have to indicate. Understood, not? So, if it is towards positive x-axis, it is I. Negative x-axis, it is minus I. Positive y-axis is j. Negative y-axis it is minus j. So these things you have to be very clear. If a vector, suppose here if you observe carefully, this u is taken upwards and towards right side, means this direction. So since a is having x component, y component, this initial velocity u must also have x and y components. Yes or no? So now let me draw its x and y components. Since it is going in upward direction like this, its x component is here, that is ux, and its y component is here, that is uy. That is what here we have discussed. Clear? So if in different cases we have to use it. So just for your understanding purpose, I have given all the 4. But here we are using this because here velocity is going in upwards direction. This is the best one, right? These both are same. And remaining depends upon the situations. So now we know that initial velocity u having x component and y component, right? If it is moving towards right side, it is positive x axis. If it is moving towards upwards, as I told you earlier, what is this here? J axis. So I have to say that this is y component of u along j axis. So this is the way we have to deal. Now, okay, I'll draw one more diagram for you, because if I put everything, if I dump everything here, you may get confused. So this one I told you it has maximum height. Now my question is that, okay, from this is the starting point from where you are throwing a body with initial velocity u, okay, from here to here, you need some time, okay. So from this point to this point, the time required for a body to move from ground to maximum height is called as time of ascent. Is called as time of ascent, the time taken by the body to reach maximum height. So in this diagram, this is maximum height. So from here to here, whatever the time that was taken is nothing but TA. TA stands for time of ascent. Time of ascent. And from here to here, whatever the time you are taking, it is time of descent. It is time of descent. Descent means coming down. The time taken by the body from maximum height to ground is called as time of descent. Suppose if a body is projected from maximum height, simply it is for released, what it may be, the time taken for it to reach the ground is called as time of descent. Now, if anyone asks you, what is the total time taken from initial point to final point, or the total time the body is in air, yes or no? From here it has started, now it is in air, coming like this and then falling down. So the total time that the body has taken to remain in air is known as what? That is next question. It is called as time of flight. Time of flight. So from here to this particular point, you have to say it as capital T. So this capital T is called as time of flight, which is nothing but ascent plus descent. The total time taken by the body to remain in air, is known as time of flight, which is actually sum of ascent and descent. Okay, so these things we are going to study now. So the next one is that in few cases, so body is thrown like this with a velocity u making an angle theta that is going upwards and then coming down. So now what is this theta known as? This is one more question. What is this theta known as? Angle of projection. Angle of projection. What is this u known as? Initial velocity, or the best way to say is that velocity of projection. Okay. Now, what is this point known as? This point is known as striking point. Then what is this point known as? Projection point, or point of projection. Point of projection. This is point of striking. Like this. Understood? And then, from starting to ending means initial to final. What is this distance known as? R. R stands for range. Whatever the horizontal distance that is present between, okay, whatever the horizontal distance that is present between initial and final or during this parabolic motion is known as range. The horizontal distance that we are consider for this parabolic motion is known as a range. Understood, na? Now, so this horizontal distance, what we are considering for this parabolic motion is called as a range. So finally, for this projectile motion, every time we cannot say that we need the velocity at this particular maximum height, or we need the velocity at this point of striking, or we need the velocity at this point of projection. So every time we could not say like that. Some cases what happens is that he will be asking you to find the velocity or its components or the angle, whatever it may be, at some unknown position. So let me say this is some unknown position. There we are interested to find out its velocity. This is one more case that we have to study. Okay. So since a body is thrown with the velocity in this direction, here also the velocity in the same direction. We have taken it as capital V. Students, remember that here capital V doesn't mean final velocity. Small u or u doesn't mean initial velocity. You should not say like that. These things are in previous chapter. In this chapter, u stands for velocity at the point of projection. Okay, in few cases accepted to say initial velocity. But whereas coming to v, we could not say final because v can be at any instant of time, right? So not only at this point, you can calculate v here or here or here, wherever which we can calculate. So we could never say it is final. It is having its own time. So what I have to say, velocity at this particular point means after some time, t, small t, okay? So if I calculate it, if I am interested to find out the velocity at this point, what I have to say is that this is velocity for time t seconds. This is the way I have to tell you. So from here to here, I have to mention that small time t. Based upon this, we are going to solve few numericals. Then only you can understand this better. Okay. So after some time, how to find out its velocity and how to find out its x component, y component. These are things we are going to discuss in further classes. Okay. So now you can have a clear view of this one. Take a time, okay, take some time, you go through this. Now, please have a screenshot of this. I'll give you 2 minutes of time. So now, children, what are the things we have discussed separately? I'm going to combine everything, okay? I'm going to dump everything in one diagram and we are going to study the mathematical equations that are related to the diagram, where I am going to prove that the motion of this body, which was thrown with some velocity u at an angle theta, follows a parabolic path. For that, we need a proof. Yes or no? So that I am going to do now. So a body is thrown with an initial velocity u, making an angle theta. Observe every time I am taking this angle with respect to x-axis. It means horizontal. That is the basic thing you have to remember, because in numerical sometimes they want to confuse you by saying that we had the body is projected an angle of some 30 degrees with respect to vertical, but you should never consider 30 degrees. Why? Because the angle that we are following here is with respect to horizontal only, that is x-axis. Suppose if they say from vertical, it means this one is 30, but we don't want this, right? So what we have to do? So use your brain. The total angle here it is 90. If this is 30, the remaining angle will be 60 degrees. So like this you have to understand and you have to follow. Understand? So every time I am mentioning you clearly again and again that the angle you have taken here it is with respect to horizontal only, not vertical. Horizontal means x-axis. Okay. Like this. So now we are throwing a body with initial velocity u, so it will go up like this and then it comes back. So now it is following a parabolic path. Okay. So in order to say it is following parabolic path, I have to make a proof of this one by using a mathematical equations. So look children, as I told you earlier, if this is u, this must be its x component, whereas this must be its y component. And this one is nothing but, since it is at its maximum position, you can call it as a maximum height. Okay. Now one more thing I wish to say is that at maximum height you could observe the body is coming down. It means that y component of velocity is always 0. So this is one important thing which you have to remember. You can ask me, sir, why you have taken 0? Okay, if I take that velocity 0, the body has to fall directly beneath of this one here. Why it is coming up to this point? This is one important question from your side. If the velocity is 0, what happens? Immediately the body which is in upward highest point up, it has to come down like this. Okay, but why it is going like this? This is what the question arises in everyone's brain. So what is the answer for this? What is the answer for this? I told you that in this particular chapter you are having components. One is x component, another one is y component of velocity. Okay. So here what I am mentioning is that y component is 0 but not x component. Only y is 0. If y is not 0, what happens? I cannot say this is highest point. If y component is there, then the body has to move here. Again, if y component is there, then the body has to move here. It means there is no sense of saying it is maximum height. If I mention maximum is, after that there should not be any other maximum. So it means that there should not be any other velocity. So this is wrong, this is wrong. So whenever I say this is maximum point, there the vertical component, that is y component of velocity, must be 0. Or else there will be some other maximum point, right? Some other maximum point. So there the velocity is 0. That is the reason why there is no other maximum point. But see, here you are having x component of velocity. Similarly, you are having one x component of velocity here. Because of this x component, it is able to move in forward direction and at some point it is reaching the ground. So what you have to understand is that at maximum height, y component is 0 and x component is present for a velocity. X component of velocity is present and y component of it is 0. Remember, because in previous chapters, in one-dimensional kinematics, I have told you clearly that at maximum height, velocity is 0. Okay, so that question arises in everyone's brain. Here also, the velocity is 0, but what happens? Only y component is 0. There in previous chapter, motion is straight line, there is nothing like x and y, only one velocity, that is 0. But here, x is different and y is different. So x component is present and y component is 0. Understood now? Now step by step I want to write equations. Since the body is projected in upward direction, as I had told you earlier, whenever it is projected in upward direction, that acceleration will be equal to minus g. Okay, so I am going to use all kind of equations. So kinematic equation, first one, that is v equal to u plus a into t. So this is what we have studied in the previous chapter, that is motion in straight line. But here the difference is that we have to take x and y components. So here I will write x, that is horizontal components. Horizontal components. Okay. And other one is vertical components. Vertical in the sense y-axis. Horizontal in the sense x-axis. Since you are saying this one as x, so here you have to put suffix x, x and then x like this. Understood? So now, what is ux? That we have to discuss. I'll give you an idea. You are saying this is v or u. Here you have taken it as u. Okay, one component is towards right side and other is upwards. I can form it in a triangle like this. So this is u and here the angle theta. mentioned with respect to horizontal. So you are telling me that this is x component of velocity. So why don't I take here x component? And you are saying that this is y component of velocity, right? So it means here you are having a y component of velocity. These two are parallel. So this could be written as y component. Okay. So this is parallel to whatever it was there here. The same thing I have drawn here. Okay. Since this is parallel to this is uy. This also will become uy. Understood? So here I'll take cos theta and sin theta. So here sin theta is equal to opposite by hypotenuse. The opposite one is uy, hypotenuse is u. So sin theta is equal to uy by u. U comes this side. So therefore uy equal to u sin theta. Similarly, if I take cos theta, that is adjacent by hypotenuse. Here adjacent is x component and hypotenuse is u. Again I have to take these two. U will come this side. So therefore x component of velocity is u cos theta. So like this I will get x and y. So the direct way of remembering all these things is that instead of writing all these things, what I follow is that, suppose if a triangle is taken like this, okay, that it be u or v or what it may be. Suppose if it is a and the angle is theta with respect to horizontal, that is x-axis. So the one that is opposite to theta is sin theta. Remember like that. The line or the side that is opposite to angle is sin theta and other one will be cos theta. This is the direct way of remembering. Okay. Instead of here, suppose here what you are doing is that you have taken u, making an angle theta. So this is opposite to theta. So directly take sin theta. Whenever the side is opposite to the angle, you have to take it as sin only. Wherever you want, you can use it. No doubt in that. And here the remaining part will be cos theta. Understood? Is it clear? So the side that is opposite to an angle theta, it can be taken as sin theta or sin component. The remaining one is cos component. Clear? So if you observe carefully everything, you are getting this ux as u cos theta, whereas uy as u sin theta. So now let me substitute each and everything. Okay. And what about the acceleration? Up in the sense this is y-axis. Then what about x-axis? In x-axis nothing is there because you are projecting in upward direction. So in x-axis it is 0. So make use of everything. So this is ux and this one is 0. Acceleration along x-axis. So the answer for x component of velocity is ux. This is universal truth. So wherever you want to find x component of velocity, it is always equal to ux. Okay. And ux here, as I mentioned, it is equal to u cos theta. So children, you directly remember that in this parabolic motion path, wherever you want to find x component of velocity, it is always equal to x component of initial velocity only. That is nothing but u cos theta. There is no chance of changing. Very, very important. Silly point, but very important. Okay. So everywhere this x component remains same. So now I have discussed about x. Let us speak about y. Here, again same kinematic equation, v is equal to u plus a into t. So about y I have to speak. So let me take suffix y. Clear? So what is uy? As I mentioned earlier, uy equal to u sin theta. So uy equal to u sin theta. What is the acceleration along y-axis? That is minus g into t. So this is the equation for y component of velocity. Okay. Now I could understand your doubt. Here I have written u cos theta and here I have written u sin theta minus gt. I am saying this value is constant. Nowhere in the parabolic motion there is a change. There is nowhere here in this motion there is a change. There is a change I am mentioning. It means that there is no change here x component. But what about the y? I have to say it is changing. What is the proof? Yes. Here there is a time minus gt. Okay. So I say that because of this t only it is changing. How? That is what is your question. Initially the time is 0. So let us take this t as 0. Then the answer for this y component of velocity is u sin theta. slowly the time is increasing from 0 to 1 to 2 and 10 seconds and 20 seconds like that. So then what happens? This minus gt value will grow. So once this negative value is increasing, automatically the resultant value is decreasing. So as I told you earlier, this component of velocity, is it changing or not? Repeating, my dear children. Initially the time t is taken as 0. At that moment, the y component of velocity is u sin theta minus 0. That is u sin theta only. Now when the time is increasing slowly from initial to some like this, it is coming, right? So it will take some time, 1 second, 2 seconds, 10 seconds, 20 seconds. So slowly when the time is increasing, so this g into t is also increasing, isn't it? So this negative value is increasing. Once this negative is increasing, the total result will decrease, slowly it will decrease. It means that there is no chance of remaining constant value. It has to decrease. So from this I can tell you that this is a variable value since it depends on time. Whereas this x component, it is constant. Nowhere it is depending on the time. Initial u is fixed, angle is fixed. But here time t is there. This value is fixed, but this value is changing, which causes overall change. Understood, na? So now we got the velocity of this body after t seconds for y component and for x component. So once we get this x and y components, as I mentioned in the previous diagram, okay, we have to find out its velocity at that instant. That is, v in a vector, you could write it as x component square plus y component square. This is the way of writing vector addition, x component plus y component square. I'll give you an idea for this also. Previously I had drawn the diagram. Here itself I'll include. So at this point I want to find out its velocity v. Okay. So now this component is x component and this component is y. So I need to find out its x, that is this one. Okay. And I need to find out its y, that is this one. I got now. And what was the time taken, that I have to calculate here. Okay. So that time I have to substitute in this. Is it clear, my dear children? So based upon this mathematical relations, we could find out the velocity either here, either here, either here, here, wherever you wish. We could find out anywhere, provided you have to know this time t. He will tell you. After 5 seconds or 10 seconds, he will mention you. There is no doubt in that. Clear now? So you got velocity. So next one is that how to find out its position. So students, before I speak about position, I'm just giving you 2 minutes of time. Have a look at everything. Okay. Take screenshot. I'll wait for 2 minutes. Now coming to the second point. Second point, that is, I want to find out the position of the body based upon the given time. So position in the sense, nothing but distance. The equation for this is s is equal to ut plus half a into t square. So this is what is the position. Okay. So now I have to find out its horizontal component, that is x component, in this way. Similarly for y also, same equation, s is equal to ut plus half a into t square. Okay. So here I have to find out y component. Clear? So let us substitute whatever the data we know. For example, this one is nothing but position of the body along y-axis for a time t seconds. Whereas this one is nothing but position of the body along x-axis for a time t seconds. Position of the body along x-axis for a time t seconds. So that is what is the meaning of this line. And this is position of the body along y-axis per a time t seconds. So these things we are going to study now. Clear? As I mentioned earlier, acceleration along x-axis is 0. So this particular value is 0 into t square. Okay. So the remaining part is distance along x-axis is equal to ux into t. So as I mentioned now, along x-axis it must be x. So this must be x is equal to ux into t. So this is the position of a body along x-axis, that is ux into t. If time is known, we could find out the distance along x-axis. Okay. So as I mentioned you, this ux can be written as u cos theta into t. Clear? So once a body projection angle, that is theta, is known and time is known, we could find out the distance along x-axis. Okay. Coming to this one, we have to find out the position with along y-axis. Position of a body along y-axis, that we need to find out here. Okay. So along y-axis we have taken as y. So taken distance along y is y only. Now what is this uy? So previously we have mentioned that ux is equal to u cos theta and uy is equal to u sin theta. Previously we have done this, right? I erased just now. So uy is u sin theta, okay, into given time, whereas acceleration along y-axis is minus g. So plus half into minus g into t square. So y is equal to u sin theta into t minus half g t square. This is very, very important, my dear. In order to prove that this is parabolic motion, I need this equation. Very important. So please look at this carefully. So u sin theta into t, I got it. So I have done like this. So this is what the equation which tells us that this is parabolic motion. Or you can say the equation for a projectile motion. Little bit simplification is needed here. I'll do it. So here you got like this. So from this equation, what we could say is that since x is equal to ux into t, I could write it as t is equal to x by ux. I could write like this. And from this, I could write it as t is equal to x by, what is x? U cos theta. And this is required to be substituted in this time t. We have to take this time t and we have to substitute here. Okay. So now let me do that, and finally I am going to get an equation that is called as the equation for projectile motion. From there I could tell you that it follows a parabolic path. Over. So now coming to this, y is equal to u sin theta, okay, into t minus half g t square. So what is t here? X by u cos theta. X by u cos theta. Okay. Minus half g x by u cos theta into square. So u and u has been cancelled. Sin by cos is tan. Sin by cos is tan. Theta into x minus half g x square by u square cos square theta. So y is equal to, okay, final equation. This is final. This tan theta can be taken as constant a into x minus of this part, that is b x square like this. So this ax minus bx square tells you that it follows a projectile motion. Okay, very important, my dear children. Y is equal to ax minus bx square. So this is the equation which represents projectile motion. Equation for projectile motion. This question you will get during entrance examinations. Is it clear? So have a note of everything, or better take a screenshot. I'll give you 2 minutes of time. Next, in the same case, we have to study its velocities at different positions also. Okay. Leave it like this. I'll discuss later. So here this is u, this is ux, this is uy, and this is angle theta. This is velocity v, x component, y component. This is angle of projection. This is some angle alpha. Let us take some elevation angle alpha. Okay. Alpha stands for elevation angle. Now, children, here I could find out tan theta. So tan theta, what is tan theta? Initially I have drawn the graph for you. Like this I have drawn. If this is u, this is x component, and this is y component, and this is theta. Tan theta means opposite by adjacent. So my dear children, the one that is opposite to theta is called as opposite side, and the remaining one is adjacent side. So this bigger one is hypotenuse. This is the way you have studied in maths, right? Now here the opposite one is y component and adjacent is x component. So this is the way to find out its tan theta. Understand? Similarly, how to find out this elevation angle tan alpha? So same way, here I am saying v. Okay, this part is v. Now this one is x component, this is y component, making an angle alpha. Now this is alpha stands for elevation angle. He will be asking you to find out this angle. How? Same concept. Tan alpha is equal to opposite by adjacent. So the side that is opposite to alpha is opposite side, and this is adjacent side, and this bigger one is hypotenuse. So what I could say is that Vy by Vx nothing but tan alpha. So like this we have to find out elevation angle. Then question arises. What is Vy and what is Vx? Initially I told you no. Y is nothing but y component of velocity after some time. With the first equation, what did you get? Please recollect. That is u sin theta minus of gt by x is u cos theta. So, as per the given numerical part, he will mention you velocity, he will mention you initial velocity, he will mention the angle of projection, he will also mention the time t. Then what is g? That you know, no? Its value is 9.8, or else you can take 10 also, no problem. So if everything is known, you could find out tan alpha. From there, you could find out alpha. Suppose if tan alpha is something like 3/4, then alpha is 37 degree. Suppose if tan alpha is nothing but 1/√3, then alpha is 30 degrees. That you will do it. Okay, I know it. So we have to know its data only, then automatically get the angle alpha. Is it clear? So the question arises, what was the elevation angle? They will give you this data and they will ask you to find out the elevation angle. Understand? Now, the last part of this concept. I am expressing this y component of velocity in time t. There is one more way to express in terms of distance. Okay, so the data may not be containing this time t. It may have distance. Then how to find out velocity? So now I am going back to third equation. Again, horizontal component as well as vertical component. Whatever I have done earlier, same thing I am going. But this is different formula. That is, kinematic third equation, v square minus u square is equal to 2as, like this. But here it is horizontal, right? Horizontal means I have to say it is x component. Vertical, what is vertical? Y component. Y, y, y. Like this I have to mention clearly. Okay. So, as I told you initially, this x and y both are same. So, I could not use this formula. So, leave it out. Because x and y both are same, no? How could I use this? You will get 0. I should not use it. Not of using that. Because you know acceleration is 0. Now, coming to this one. You want to find Vy to substitute here. So, Vy square minus of Uy is u sin theta whole square to acceleration along y-axis is minus g that we have studied, because the body is going up. Whenever the body goes up, it is minus g away from the earth, and distance is y. Or you can take h like this. Okay. Now Vy square, this minus going other side is becoming plus. U square sin square theta minus 2gy. Then what is Vy? Root of u square sin square theta minus 2gy. So now, if the time is given, this is the formula we have to use to find out angle alpha, elevation angle. If time is not mentioned, if they give you the value of y, then you have to use this. So, same thing is continued here. Root over u square sin square theta minus of 2gy divided by x component is u cos theta. So, this is other way of finding, okay, angle alpha, where angle alpha is called as a elevation angle. Angle alpha is called as elevation angle. So, from this particular concept, what you have to understand is that projectile motion, firstly. Children, repeating for you, what is projectile? Whenever a body is thrown with a velocity u, it makes an angle theta with the horizontal, so that it is following a parabolic path. Clear? Second thing is that we have to make a proof of it in all the ways. That is, we have to find its velocity at different points, position at different points, and elevation angle. So, all the three are discussed here very carefully by taking kinematic equations. Now, you can note everything, okay. I'll give you some time, 2 minutes of time, you can have a screenshot or you can note it.